Alrighty, in this video, I'm going to talk about how to graph cosecant and secant graphs. And what do you notice about these graphs of cosecant secant? Well, you'll see here that I have an imaginary sine function going around where I have my maximum and minimum points being my reference points for my cosecant function. Likewise, same thing here with my secant function. I have reference points of my maximum and minimum based off of my cosine graph. So what we're going to do with these problems is create a sine or cosine graph and then use that to help us figure out the cosecant and secant graphs. All right, so let's look at number 16 and figure out what's what. My amplitude is 1. My period is 2 pi over b, or just 2 pi. I have a phase shift of left pi over 2, and then I have a vertical shift of up 4, or my midline. So I know that I have a midline at 4. Now, recall that a cosecant function is the same thing as a sine function, but this time it's a negative sine function. So I'm still going to start at my midline, but I'm going to go down. Before I do that, though, I kind of need to take care of my phase shift. So I have a period of 0 to 2 pi, and then I have a phase shift of pi over 2. So I'm going to subtract pi over 2 here, and I'm going to subtract pi over 2 here. Once I do that, I'm going to find quarters, and that's going to give us our lovely reference point. So this is going to be pi. This is going to be pi over 4. No. No, why did I say pi? Yeah, sorry, that should be pi over 2. This should be 0. And then this should be pi. All right, I'm going to start at negative pi over 2 with my sine function. And then I am going to go down 1 because that's my amplitude at 0. Make sure that you pay attention to your axes. Then I'm going to go pi over 2. Then I'm going to go pi. Then I'm going to go 3 pi over 2. And of course, I'm just going to repeat this process. And then I am going to lightly graph this. Now, do you have to graph it? Not necessarily, but it does help you look at the visualization on what's going on. Based off of our cosecant function, we are gonna go up with our maximums and then go down with my minimums. And of course, we can't just go down like this. There is an imaginary asymptotes, and those asymptotes are gonna be your values of your midline. So right here would be an asymptote, so I would just be careful. Don't cross that. This one has an asymptote somewhere right here. Same thing here. I have my 2 midlines right here and right here, so I don't want to cross that. And then same thing here. I have a midline right here. midpoint right here and right here somewhere. I'm going to do the same thing for my maximums. Unfortunately, it is going to be off the graph, which I'm not a big fan of, but it is what it is. And then if you were to erase everything, which you do not need to on the quiz or tests, you're going to get something like this. Now, if you graph it like this without any indication of your sine graph, it's going to be wrong. So make sure that you have the imaginary sine graph with you so that you at least know what's happening, especially in the later questions whenever I ask you to convert this into maybe a positive cosecant graph or a negative secant graph and the phase shifts and transformations there. All right, I am going to do another problem, and this one I'm going to look at a secant graph. So it looks like it's 17. Your amplitude is 3. Your period is 2 pi over b. In this case, it's just 2 pi. Your phase shift is right pi over 4. And then your vertical shift is up 1, aka your midline. Now, a secant function corresponds with a cosine graph, so we are going to start high first. But, of course, before we do that, I kind of need to figure out what my reference points are. So my period would be from 0 to 2 pi. And then I'm just going to add pi over 4 to it. Then find your midpoints. All right. I am going to start graphing at pi over 4. And I'm going to start high. Since my amplitude is at 3, I'm going to start at pi over 4 at my midline and then go up 3. Then I'm going to go to 3 pi over 4. Then I'm going to go back down. 5 pi over 4, 1, 2, 3, 7 pi over 4, and then 9 pi over 4. Repeat this process. Until you get a happy cosine graph. And like I said earlier, you don't necessarily have to graph the whole thing. As long as you give me the points of the graph, you'll be fine. Because now I could just look at my maximum and minimums and just go down, taking notes of my imaginary asymptotes of my midline. Oop. And your graph for 3 secant x minus pi over 4 plus 1 should look something like that. All right. These examples, of course, are kind of self-explanatory in terms of what we have been doing. So at this point, what I'm going to do now is look at a problem where I ask you to turn something into something else. So notice how on number 20, I ask you to graph 2 secant x minus pi over 4 minus 1, and then I want you to turn it into a positive cosecant graph, aka find the equation of the positive cosecant graph. My amplitude is 2. My period is 2 pi over b. In this case, it's just 2 pi. I have a phase shift of right pi over 4. And then I have a vertical shift of down 1, aka my midline. Okay, and I'm pretty sure I have right pi over 4 with a period of 2 pi somewhere. This thing right here. So we're going to use these points. And we are going to take it as a cosine graph. But this time, we are starting high. And we're starting at pi over 4. So looking at -1, pi over 4 right here, 2. Then 3 pi over 4, back to the midline. Then we're going to go low, then back to the midline, then up. Repeat this process. And then you can begin graphing. Ooh. All right, so there's your graph of 2 secant x minus pi over 4 minus 1. And then it tells you to turn it into a positive cosecant equation. Remember that a cosecant equation is basically a sine graph. So where is my sine graph in terms of this regular cosine graph right here? And then figure out what my phase shift is. Remember that my sine graph, it's going to start at the midline. So right here, and then it is going to go high. So I'm not going to start here because if I go to my midline, I'm going to go low. But if I start here, I'm going to go high. Meaning that this point right here is going to be my little phase shift. So if I have a positive cosecant graph, I have y is equal to 2 cosecant x plus pi over 4 minus 1. The only thing that we're changing is our little phase shift. Since we have a phase shift of pi over 4 to the left, that's why it's plus pi over 4. That's going to give us a cosecant graph. I'm going to do one more, which is 21. And I really like 21 because you'll notice that it's not factored, which means that you have to factor it or else you're going to get the phase shift wrong, and that's not going to be pretty. Your amplitude is 1. Your period, well, before I do that and before I find my phase shift, I am going to probably factor out my argument. So I have negative secant 2x plus pi over 4. My period is 2 pi over b, or just pi. My phase shift is left pi over 4. So I'm going to go from 0 to pi. Then I am going to first find my phase shift of left pi over 4. And then find the middle of that. So that's 2, that's pi over 4. This is 0. And then this is 2 pi over 4. Or just a half. All right, so I'm going to start at negative pi over 4. And since this is a secant graph, this is going to be a cosine graph. But also it's going to be a negative cosine graph. So instead of starting at my midpoint, I'm going to start low, and I'm going to start at negative 2. All right, and then I am going to go back to 0. Oops. Then up to pi over 4, down to pi over 2, and then down to 3 pi over 4. I'm going to repeat this process. Going the lazy route and just copy and pasting, LOL. Right here. All right, once we get that, I'm gonna find my maximum minimums, graph those, taking account of my asymptotes of the midline. And then once I do that, we are going to talk about the positive secant graph. Now, with a positive secant graph, this is essentially saying, how can I make this a positive cosine graph? Well, remember that a positive cosine graph starts high first, and then it goes to the midline. Well, I go high right here first, and then it goes to the midline. Meaning, if I were to write the equation of the positive secant graph, then I'm just going to erase this. Then I have y is equal to secant to x minus pi over 4 minus 1. And notice how I still kept it in the factored form because, remember, I'm still keeping my period of pi based off of this 2. The only thing that I'm changing is that this is just right pi over 4. All right. I'm not going to do 22. I think you guys can do that. And then I'm not going to do the others, but you can check the student notes folder for the work and the key for those.